Welcome back to the third paper, going through the November 2022 Foundation paper series. We'll just get straight into it. Make sure you got a calculator because it's a calculator paper. Okay, very similar. We've had these before. Really similar ones in the other two papers about ordering numbers. Again, like I said last time, we'll go a column at a time. So if we look at the ones column, if you really wanted, you could line them all up like 0.41, 0.5, 0.46, 0.408, and then fill any gaps with with zeros in. And then literally just look at each column. So we're going from smallest, so all these are the same. Okay, this rules this one out straight away. Now we're looking at this one. They're all the same, so we go to the next column. We've got a 1, 6 and a 0, so this must be the smallest. Okay, now again, we're looking at this. Okay, we've got the 1 next is the smallest, so 0.41. And then 0.46 is the last one with the 4s, and then 0.5. Alright, don't overcomplicate it. That one shouldn't be too bad. Okay, value of the 2 in the number 12,345. I personally think the easiest way to do this, instead of writing it in words, I'd literally just write the number. So we're looking at the 2 here. Okay, what column is that? It's the thousands, right? So it's 2,000. 2,000. Right, that's all you need to do. Don't overcomplicate it. 4/5 is a decimal. Again, we've got to be quite careful here. What I would suggest is writing this fraction over 10. A lot easier to do when they're over 10. So we're doubling this to get to that. So we're going to double the top. So we get 8/10, which you might just know, which is 0.8. But you could also put it over 100. If you really wanted to be super careful about it, times it by 10. Times it by 10. So it's 80 over 100, which is 0.8. Or 0.80, same thing. Alright, either works. Okay, right into the nearest whole number. So essentially, it's 19 point something. So if you look at 20, 19, it's here. It's quite a horrible number in the sense it's not easy. But you just got to work out, is it closer to 19 or 20? That's what you've got to do. We just need to, if we're round to the nearest whole number, we need to look at the ones column here, because the ones is the nearest number, right? So we look to the right, is that going to round it up to 20 or down to 19? Well, that's going to go down to 19. So our answer is just 19 for that one. List the numbers. Okay, so we're looking for a multiple 3. So multiple 3, that just means the 3 times table. Okay, so if you wanted to just write them out, 3, 6, 9, 12, 15, 18, and found it. 18 is the one we're looking for. So that works well for us. And that's your first page. Right, we've got a graph here showing information about the average monthly temperature in degrees in Amman. Right, we're looking, and the question says, for how many months was the average monthly temperature greater than 16? So we need to look at average monthly temperature being greater than 16. So if we draw, might as well, we get no reason why not. We can draw on this. Draw on 16. Right, and we're just going to pick all the months that are greater than 16. It has to be greater. It can't actually be 16. So we've got May, that's 1, June, July, August, September, October, and that's it. Alright, so that's 1, 2, 3, 4, 5, 6 months. Alright. Write down the 2 months have the same average monthly temperature. So we're just looking for any where the numbers are the same. Now you can just literally look one at a time. No, no, nope, nope, yep, two numbers here. There's this month and this month, they've got the same number, both 20 degrees, so that is May and October. So May and October. That's the one. Alright. Okay, our first proper wordy one. The words have come out for this one. I haven't actually used a calculator yet, so we might get to use that soon. 208 bars of chocolate were sold from shop. A quarter were large. Okay, so let's look at some facts, key bits of info. 208, quarter, large. The rest were all small bars. So the rest, meaning, apologies, didn't mean to do that. The rest, meaning 3/4. Okay, so we've got 1/4 are large, and the rest are small. So if you had like a drawing, that much is large, and the rest, these 3 out of 4 are small, and that's 3/4. Alright. Okay. All the large ones, we've got some money, some costs, were sold for £1 each, that's the large ones. And all the small ones were 60p each. And then we can work out the total amount of money for which 208 bars of chocolate were sold. Gives your answer in pounds. Alright, so let's start off finding out how many were large. Okay, so if we look at the large ones, okay, so we just do 1/4 of 208. So we're going to do 208 divided by 4, and now the calculator's coming out. That is 52. Alright. And then small, so we're doing 3/4 of 208. So 208, we know what 1/4 is. Okay, so if we know 1/4 is 52, we need to triple that to find out what 3/4 is. So we're doing 52 times 3. It's 156. Or, I mean, you could have just done 208 take away 52. Either works, to be fair. Okay, and we've got some costs. So all the large ones for £1 each, all the small ones for 60p each. So we've got 52 times 1, which is £52. So that, again, that's the large. And the small, 156 times, now 60p, I'm going to put in pounds because the answer, they want it in pounds. That is £0.60. So I'm timesing it by 0.6. That is 93.6. Now, because it's money, I am going to pop the 0 on the end, just because that's how you normally have money. You got 60p, and then we'll total those up to give us the total amount. Again, I'm just using my calculator for all of this, rather than doing it myself. So £145.60. Right, again, just popping the 0 on the end. That's another page done. Okay. We've got 4 students playing some sort of game. Table shows number of points each student has. We've got Ali, Barbara, Calliope and Dinesh. Barbara has more points than Dinesh. How many more? Okay, so it's quite a not too bad one. So Barbara's got 121. Dinesh has 19. Again, just use calculator, find the difference. 121 minus 19. 121 minus 19, 102. Just use your calculator, don't bother doing it yourself. Just write the calculation down so you can, show your workings, but honestly, don't bother writing it down. Mean number of points. Now, I always say to my students, out of all the averages, the mean is mean. It's horrible. Makes you do a lot of effort. You've got to do some adding, you've got to do some dividing, there's a lot going on. So we're going to do a lot, right? We're going to add up all our numbers, the amount of points we have. So we've got 143 plus 121 plus 45 plus 19. And we're going to divide that by how many people there are. How many numbers there are, essentially. There's 1, 2, 3, 4. Okay, so we add them all up and divide them by 4. Again, just get your calculator out. I'm doing it as we speak. And you get 82. Right? Honestly, quite straightforward when you know the steps. Really straightforward steps. Use your calculator, add them up, divide them by 4. Alright? Another page done. graph, lovely. Okay, graph with coordinates. Remember, first things first, it says write the coordinates of A. You go along the corridor first, so that's minus -1. And then you go up the stairs, which is positive 2. Okay, so -1 and 2. Again, use the same logic to do part B, which is marking a coordinate. So it's 1, 4, so we're going to go along 1, and up 4. 1, 2, 3, 4. Alright, and nice cross. If you want to be really good, put B. Alright. Then last but not least, it says on the grid, draw the line with the equation y equals -3. Now what that means is that the y value is always going to be -3. So whatever x value you use, your y value will always be -3. That's what it means. So you could put a point there, put a point there, there, there. But it doesn't say put some coordinates, it doesn't say that. It says draw a line. Okay, draw a line. So we need to get our ruler out. And where you see all those crosses, they come together and you draw a lovely, beautiful line all the way across. Alright, so now I can say that is the line y equals -3. Okay, and that's 3 nice, quick, easy marks. Okay, we're looking at terms of a sequence. First 3 terms, write 2 numbers that could be the 4th and 5th terms of this sequence. Right, I would always look at it and see how much is it going down by. That's the easiest way, I would say. So it's going down by 4 here. Then it's going down by 3. So then if it's going down by 3, it's going to go down by 2 next. And then go down by 1. So it's going down by 2, we have 11. Going down by 1, we get 10. So 11 and 10. And then just write, it says write down the rule you used to get it. Well, subtract 4. Then subtract 3. Then, I might try -2 now. Then -1. Alright. That's fine. That's the rule. That's what you've done. No worries. Moving on. Okay, volume of a cuboid. Now, volume means all the stuff inside. If you imagine you had a box, and it's what's inside, like all the stuff you'd have in the box, would be the volume. The max, if you filled the box completely, that'd be the volume of the box. Alright, so we've got a cuboid here. Now, they're actually quite straightforward, but they're generally, all you have to do for the volume of a cuboid is you're timesing how wide it is, by how far back it goes, by how tall it is. So you're just timesing 3 numbers together. So we're doing 8 times 4 times 5. Alright, and again, you can use a calculator for this, no need to do it yourself, and you'll get 160. Alright, and the units I've already given you, but they are centimetre cubed, because you imagine doing centimetres times centimetres times centimetres, you're cubing it essentially, timesing it by itself. Okay, we've got what looks like a ratio question here. We've got 3 people. Amal, Gemma and Harry have a number of sweets. Gemma has 6 times the number of sweets that Amal has, so that's going to be important to know. 6 times the amount Amal has. The number of sweets that Harry has is half the number that Gemma has. This is not an easy one, you can tell it's not easy, because it's a 3-part ratio, 3 parts. But we know Gemma has 6 times the number that Amal has. So we can straight away write down that she has 6 times the amount that Amal has. 6 times. And it also says that Harry has half the number that Gemma has. So we just need to find half of this, and that'll give us the number here. So half of 6, well, that's just 3. Okay, and that's literally it. So it looks quite scary. If you weren't sure, at least get something down. You'd probably pick up a mark for just saying 1 to 6 in the first place. So, honestly, you want to be giving that one a good go. Quadrilateral, all about angles. Okay, so we're looking at the different angles in this quadrilateral. Work out the size of the angle labelled X, which is this one here. All you need to know is gives you a bit of a clue. You've got to give a reason for your answer, so you need to know some sort of rule or reason. Well, angles in a quadrilateral add up to 360 degrees, so I'm actually going to write that one first. Right, they add up to 360 degrees. So to find out the missing angle, 360 minus 120 minus 120 minus 80. Just take away all the other sides and you'll get your missing piece. Again, calculator's fine, use that I would. 40 degrees. Alright. Diagram below shows a triangle. Diagram's wrong, explain why. Well, my first instinct is to add up all the sides and see what we get. So if we add 60 plus 50 plus 80, I bet you it will not add up to 180, which it should. 60 plus 50 plus 80 is 190. So I'd say angles in a triangle add to 180. This adds to 190. So the diagram must be wrong. Or is wrong. Right, that's fine. Right, that's perfectly good reasoning. Onwards and upwards. Okay, we've got a bit of a conversion graph here, so you can change this graph to go between ounces and grams with your measurements they are, for like usually using the cooking. And it says change 850 grams to ounces, so we're looking for 850 grams. So we'll look at this one, 850, and we'll just follow that along. And then we'll follow that down. Okay, 30 ounces. Right, and then we're in a bit of a weird one, because it says 80 ounces. Well, if I look at my ounces, it only goes up to 35. So we can't go directly there. But what we can do is find a multiple of it, or some 80 as a multiple of another number, I mean. So I'm looking at this 20 here, and I'm thinking, well, if we can work out what 20 ounces is, 20 ounces, we can just times it by 4 to get the grams. So if we follow up what 20 ounces is, now it's a bit awkward because it seems to be in between two. Okay, but we follow it along, we get, so this must be 550. Okay, so look, this would be 560, this is 570, so I'm saying 565. Now you'd probably get a little bit of a range for this one as well, because you might say 560, you might say 570, but we're just going to multiply that by 4. Okay, and that will give us our missing piece. Again, calculator's coming out. 2260. Okay, but you could get anything in the range of 2238 to 2296. So there's a bit of a leeway there. So if you didn't get exactly what I got, don't worry, you might be right. Okay, question 15. Okay, we're looking at a question to do with weight and money. Okay, so we've got 2.5 kilograms of onions and 2 kilograms of carrots at cost a total of £2.36. 3 kilograms of carrots cost £1.74. Stuart has £2 and he wants to buy 4 kilograms of onions. Okay, this is definitely quite a tricky one because the carrots are a bit of a throw off, because we do need to use that information about the carrots, but he doesn't even want to buy carrots. So what we're going to need to do first is find out how much 1 kilogram of carrots are. So we can find that out, we can find out how much 2 kilograms of carrots are, and use that to subtract from the total to find out how much 2.5 kilograms of onions are. Essentially, it's quite a few steps, which is why how many marks is 4, I reckon? 5 even. Okay, let's start with the carrots. So I'm just going to write carrots. Okay, so if 3 kilograms equals £1.74, so 1 kilogram, we need to divide that by 3. £0.58 or 58 pence. So therefore 2 kilograms. I'm going to double that. £1.16. Okay. So if we've got 2.5 kg of onion, must be £2.36, take away that £1.16. So let's work that out. £1.20. Okay, so that's for 2.5 kilograms of onion. But let's just write onion here. Okay, we need to work out 4 kilograms of onion. Okay, it's not very easy to go from 2.5 to 4 though. So what I'm going to suggest is we find out what 1 kilogram is. Okay, and to do that, we need to divide by 2.5. It's 48 pence per onion. Okay, and we want 4 kilograms. So we're going to times that by 4. So it's going to cost £1.92. And our last step will be that reasoning. How much money has he got? Luckily for Stuart, the bloke's got £2. So, yes, Stuart has enough. You could say something like he will have 8p change. Okay, because £2 take away £1.92. Yeah? Okay, and that'd be perfect. That'd be great. That's a great little answer there. Okay, we're interpreting a pie chart. It doesn't actually look like we're doing much with the pie chart, to be honest with you, apart from saying what's wrong with it. So, Salim's drawn a pie chart about potatoes, box of potatoes, and so we've got the 90 potatoes for Jersey Royal, 105 for Charlotte, and the Maris Pipe's 105. One thing I can already say is misleading is there are no labels on this pie chart. How are we supposed to know? So, I mean, you can tell which one's which if you've got the table, potentially, because you know that these two are the same, so there must be those two. But no, there are no labels. Now, if you actually calculate what this should be, these values should be, in terms of the degree, the angles. So if you add them all up, add all these three up, 90 plus 105 plus 105. So these add up to 300. Right, okay. Now, they don't add up to 360, so I wouldn't expect a 90-degree angle for that Jersey Royal one. To calculate that angle, you do 90 over 300 times by 360, because it's a fraction really. Let's see what that brings out. See, that gives 108 degrees. So this one here is incorrect. Okay, that should be 108 degrees. So we can say the angles are incorrect. The Jersey Royal should be 108 degrees, not 90, for example. Because that's quite clearly supposed to be a right angle, but it shouldn't be. Right, some quick ones now, rounding it to 3 significant figures. So the first significant figure is this one, second is this one, third is this one. Okay, so it's the third one along that's not 0. So we're just going to look at it. So it's going to be the 8 and the 7 will stay the same. Alright, so essentially we look at what that column is, that's the hundreds column. So all we're being asked to do is round this number to the nearest 100. Right? So instead of it's either close to 500 or 600, there's a 6 here, rounds it up. So it's 8, 7, 600. Right? 8, 7, 600. Alright? Okay, this next one, I'm not going to go through quite in the same way to show you as such. I will get a calculator app out to make it clear for you. Okay, so what I've done is I've literally just got the calculator app up. This is going to be a bit of a weird way, but the first button I'd be pressing is the fraction key, because we have essentially got a fraction there. So if we do the fraction key first, so we can have all the stuff on the top and we can start writing it in. Next thing, we're going to want to put a bracket. Okay, you want to put that bit in the bracket first, and then we just need to start writing the number. Okay, so we've got 3.2 plus 3.7 and close the bracket, and then it says times 4.9. Okay, so that's all on the top, and then we're just going to pop ourselves to the bottom. Right, where's it gone? Am I done? What? There we go. Sorry, that was a bit weird. And then on the bottom we've got 5.3 minus 2.8. Right, and then let's just see what it is. Oops. Apologies. Sorry, I meant to press go. Bit weird because I'm doing it on here instead of how I would normally do it. But there we are. Okay, so it's 13.524. And it's asked for it as a decimal, so that makes most sense. Sometimes it might pop as a fraction, in which case you just need to convert it to a decimal. Alright? Sorry about that. That was a bit of a faff one, that. Right, number 18. Rotation. Alright, this is where you get your tracing paper out. Alright? Okay, so I've got my tracing paper. I've just put it on like here, this pinky sort of paper here. We just need a couple of bits of information to do this one. So we need to know how much we're rotating it. Okay, we need to know the direction. So anti-clockwise is this way. If you imagine a clock, it's the other way. Okay, and it's about 0, 0. So that's our centre point. So I'm going to draw the centre point underneath the tracing paper. Do it in pen. Okay, but I will also put it on top in a moment. Alright, and then what we need to do is get your tracing paper lined up so it's facing like this, upwards. Okay, so vertical piece of paper upwards, right? And then cross off the corners of your shape, like so. Right? And we're going to do a rotation in a moment. Now, what you would do is you'd put your pencil on top of the centre point and you hold it on there. Now, I've been fiddling about with how to actually show you how to do this because it's a bit tricky because I haven't got a paper version. So the way I'm going to show you is a bit unique. I'm just going to use the software I've got here already. Okay, but essentially you get it on the corner, this centre point here, and then you spin the paper so it turns in that direction. You kind of hold the pencil on the top and then spin the rest of the shape underneath it like that. So you'd be spinning the actual paper 90 degrees so it turns horizontal. Okay, but then you keep this first point here the whole time. So I'm just going to rotate it. Okay, so it should end up over here. So if I just line that up there. Alright, obviously I've done the whole thing so it looks a bit strange. Just going to tweak it slightly to fix it, make it look better. And then what you do is you take off your tracing paper one piece at a time to do a cross at a time. So I'm just going to move it out of the way and then do my first cross. Normally I try and memorise one point at a time. And then I see it's gone up here, cross 2, and like that. And then you just connect up your shape. Alright? And your tracing paper should end up being horizontal to how it was before, so it ends up sideways. Alright, I know I tweaked mine slightly, so mine's a bit square shaped, but you get the idea. And then you just get your ruler, draw out some nice neat lines so it looks good. You want it to be nice and presentable for the examiner, so they have no excuse not to give you the marks for it. There we are. Alright, and now that's been rotated 90 degrees anti-clockwise, about 0, 0. Okay, number 19, got Carly cycling to her friend's house. She stays at her friend's house for a number of minutes, and then she cycles home, and it's her journey. Okay, so we've got travel graphs, we've got time and distance. Alright, first thing says, how many minutes did Carly stay at her friend's house? Now, you might be thinking, how am I supposed to know that looking at this graph? Well, if you look, is there ever a point where she's making no distance? She's not moving. She's at someone's house, so she's not travelling. Right, and that's going to be this, we're looking, distance is this up the y-axis. Okay, is there ever a point where it's not going up? And that's here. That's this flat bit here. Right, so between 8:30 and what's this? 8:45. This is in between 8:40 and 8:50. She's not travelling. So that's 15 minutes. Right, that's 15 minutes. Alright. Then it says, how far is Carly from her house or her home at 8:50? So 8:50, we need to look at where she is. Here, follow it across. And then we can see the distance from home. Just make it really clear. Okay, so what have we got here? 4.2, 4.4, 4.6, 4.85. So 4.2, 4.4, 4.6. Alright, just look really carefully. If you're not sure straight away what the scale's going up in, try a few things. Normally, the more you do, you kind of just see it and you can tell how much it's going up by. If you tried 4.1 to 4.3, 4.4, 4.5, you'd realise that's not going to get you to 5. You can just try a few variations until you get the right one. So that's 4.6. Alright. And then it says work out Carly's speed in kilometres per hour for the first 20 minutes of her journey. So we're just looking for the first 20 minutes, which is a nice straight upwards journey like that. Nice and straight. Okay, so all we need to use is, we need to know speed, distance and time. So, first things first, we've been told it's 20 minutes. Minutes is not ideal. We want this in hours, really. Okay, we want it in hours. So we'll come back to that in a second. And then we've got how far did she go? Well, she went 4 kilometres. Okay, and to work out the speed, it's the distance divided by the time. And you might be able to work that out by looking at the units as well. Because kilometres per hour means kilometres divided by hour. Okay, if you notice that measures distance and that measures time. Okay, so that's all that we're doing. But we do need it in hours. Minutes is not going to work for us. So we're going to have to change that minutes into hours. Okay, so we know there are 60 minutes in 1 hour. Okay, but we've got 20 minutes. Okay, so we're dividing that by 3. Dividing it by 3. So it's 1/3 of an hour, or 0.333. If you put that in your calculator, 1 divided by 3, you get 0.33333. Okay? Okay, or we're essentially doing, that's 1/3, right? So we're going to be doing our kilometres, so that was, what was that? Let's have a look again. That was 4, so we're doing 4 divided by, and then in hours, it's either 0.3333 or just 1/3. 4 divided by 1/3, put that into your calculator, and you get 12. If you put divided by 0.3333 and put 3's in, you'll see that your answer is very, very close to 12. Or it's like 12.001 or whatever. Just put 12, that's fine. Okay, because that would be to 1 decimal place or even 2 decimal places. Alright, so either would work for you. If you're not comfortable putting divided by a fraction in, because that can be a little bit tricky. Right, next. Oh, recipes. We've got to love a recipe. Alright, we've got a list of ingredients. We're making 10 scones or scones, wherever you're from in the country. We've got the ingredients. We've got some guy, Martin. He's got some ingredients, but we don't know if he's got enough. Let's find out. He wants to make 25 of them. He's not got enough of some of the ingredients. Work out how much more of each ingredient he needs. He wants to make 25. So, the ingredients for 10 has been given to us. Okay, we want to know, we need the ingredients for 25 to work out how much more he needs. So to get from 10 to 25, we are timesing that number by 2.5. Alright, 10 times 2.5 will give you 25. So we're going to do that to all our numbers. Every single one. Okay, so let's do it. 80 times 2.5. It's 200. So 200 grams for butter. Then we've got 350 times 2.5. 875 grams for flour. 30 times 2.5. 75 grams. And 2 times 2.5 is 5 eggs. Okay, so he needs, so we put here, he needs 200 grams of butter. Okay, for the flour, he needs 875 grams. For the sugar, he needs 75 grams. And for the eggs, he needs 5 eggs. Okay, and he has, at the moment, 100 grams of butter. He has 1,000 grams of flour. 1 kilogram is 1,000 grams. He has 50 grams of sugar, and he has 4 eggs. Okay, so we need to work out how much more he needs. So he needs 100 grams more butter. His flour's fine, he's got plenty of flour. He needs 25 grams of sugar. Okay, so we go from, he's got 50, he needs 75, and he needs 1 egg. And then he's all good. Ready to do his baking, once he's got all that. Alright. Okay, 21. Make A the subject of the formula. P equals 3A take away 9. All that means is get to the point where it's A equals ... Or if it's on the other side, A equals ... Right? So aim of the game, look at your formula. We need to pick which side is going to be the sides for the A's. Now, I would just use whatever side the A's already on. So I just rewrite the formula out, which is underneath, a bit bigger. The A's are on the right, okay? 3A on the right. So we're going to make that our A side. So all that means is anything that is not an A, so this 3 and this 9, needs to go to the other side somehow. Alright, and we're going to take a couple of steps to get there. If you have seen my other videos, I have said about this 3 is going to be moved last because it's attached to the A. They're attached to the hip, right? So it's got to be the last thing to move. So we're going to move this -9 first. And to move a minus, we do the opposite, which is plus. So we're going to add 9 on. Okay, so it disappears from here. And we're left with P plus 9 is equal to 3A. Okay, then we're nearly there. We need to get rid of this 3, which is currently being multiplied by the A. So these guys are times them. To get rid of the times, we do the opposite. Okay, so we're going to divide by 3. So now it's gone. We've got A equals, okay? And then, don't overcomplicate it, P plus 9 divided by 3. And that's it. That's legit. Job done. Don't need to write any fancier than that. That's fine. Alright. Okay, now we're looking at a ratio. Rob has been asked to divide 120 in the ratio 3 to 5. And he's done some workings. He's divided it by 3 and then he's divided it by 5 and said, that's good, that's great. But he's wrong. He's done something wrong. Okay, and you got 1 mark, you've just got to describe what he's done wrong. Now, there's going to be a few options in how you might want to approach this. I mean, first thing, if he added up 40 and 24, he's supposed to get 120. He's going to get 64, so he's nowhere near. So the thing that he should have done, firstly, is he should have divided 120 by 8. Because that tells us, if we drew the boxes, now you wouldn't need to do all this to get the mark, by the way, just to be clear. If you drew the boxes 3 and then to 5, if you divide it by 8, so 120 divided by 8, you get 15. Now that will go in every single box. Okay, so you'd get 45 for the first one, and then 75 for the second one. And that will add up to the 120 that you're looking for. So what Rob should have done, Rob should have, or should, divide by 8, okay, to get 15. And then multiply by 3, okay, and by 5, e.g. you get 45 and then 75. Now you might not need to do all those words because you've shown some workings there, so you've kind of shown it, but it is good to have that last bit of what the ratio should look like. Alright. Okay, we've got a very wordy question here. Now, questions like these is where you might want to whip out a two-way table. You don't have to use a two-way table, but it works quite nicely. Okay, I'm going to show you it without a two-way table, only because I think instinctively, if you were seeing this question, not many people would automatically think to do it as a two-way table. Yeah, I think a lot of people would just try and problem solve and find the missing pieces, and that's what we're going to do. Okay, we're going to use what's been given to us to help us. So we've got 200 students, so that's the total. Okay, they either choose from French or Spanish or German. So we've got 3 choices, French, Spanish, German. Okay, and then we've got boys and girls. Okay, so we've got 90 that are boys and the rest are girls. So we're going to kind of split this up into pieces, alright? So we've got the total is 200. Okay, we've got boys is 90. And we've got girls must therefore be 110 because they've got to add up to 200. Okay, first step. Of the 200 students, 90 are boys and the rest are girls. And then we've got Spanish, German and French to worry about. So we've got Spanish, we've got German, and we've got French. And for each of these, we want to work out the boys and the girls. Boys. In fact, let's just do it being boys, girls. Boys, girls, boys, girls. So even though this isn't a two-way table, it's actually kind of similar, similar sort of idea. Okay, let's go through what we've been told. Okay, so we know that 70 choose Spanish. Okay, so these two are going to add up to 70. I'm basically drawing a two-way table at this point. I don't know how I've not realised that this is what I'm doing. Okay, and 60 of the 104 who chose French are boys. So there's 104 that choose French. We've been told that now. Okay, and 60 of them are boys. So you might be thinking we can already work out how many are girls. So let's just do that straight away. Take 104, take away 60, gives us 44. So we've already, French, we've all sorted now. Okay, and also says 18 girls chose German. Lovely. Now, it's all about filling in little gaps that we can find. Right, so let's have a look. So we have now got, I'm feeling, don't know about you guys, this gap here. Now the reason I'm feeling this gap is because we know that the total amount of kids is 200, right? And we've got 70 doing Spanish, 104 doing German. So there's a few, basically, sorry, I meant French. So then we've got a few here that must be the rest. So if we do 200, in our calculators we do 200, take away 104, take away 70. That will give us the amount doing German. So there's 26 doing German. Now we can work out how many boys are doing it, because it's got to add up to 26. So what is that, 8? 8 boys doing German. All right. Now we know, oh, we're basically done, guys. We don't even need this gap. We could just fill it in for fun. But the total amount of girls needs to add up to 110. Okay, so we can do 110, take away 44, take away 18. So it must be 48 doing Spanish. We literally filled that in for fun. We didn't even need to do that. But, oh well, I don't know. Okay, and then we can either get this gap by doing 70 take away 48. Right, which is 22. But we can check that it's right, by also doing 90 take away 8 take away 16. If we get 22, guys, we are in for it. Okay, so 90 take away 60 take away 8. And we get 22. So 22 is our answer, because that's what the question actually asked. We'll remember, how many boys do Spanish? 22 it is. Right? And if I'm honest, I actually think it's a bit harsh. It's only worth 3 marks. It's quite a lot of work we just put in for 3 marks. But, oh well, moving on. Oh my goodness, Katrina with her tractor and her tanks. Okay, we've got cylinders. Important information to know. It's a cylinder. Okay, and they're filling these cylinders. Alright, so we've got its diameter, we've got its height. We will use that in a moment. They're going to be filled completely. If I went back to that volume question of a cuboid, this is giving me volume vibes. You're filling something up completely. The inside's getting filled. Alright, it's getting fertilizer and water. This is not an easy question by any means, by the way. Even the word volume's been thrown in there now. It's got a ratio, which we will use, but we'll do that in a minute. Okay, and she's got 32 litres. If you think litres, I'm thinking water bottles. That is, you fill up your water bottle, don't you? So that's the volume of your water bottle, for example. Okay, and we're going to use that to help us. Crikey, here we go. Alright, first things first. Let's find the volume of this cuboid here. The cuboid. We're going to find the volume. Now, volume of a cuboid. Okay, you are given the area of a circle, alright, in your formula book. That is pi r squared, or pi, let's write that really clear actually. Pi times radius squared. The radius of the circle goes from the middle to the end, so it's not 80, we need to half that, it's going to be 40. And so the volume of a cylinder, the volume, okay, is the area of this circle times by however tall it is. So we're going to times that by the height. Okay, that's our first step. So let's do that. Let's just replace the pi stays the same because it's just, it's pi, times by the radius, which we've worked out as 40, squared, times by how tall it is, which is 160. Okay, and I can tell you now my units will be centimetres cubed, because this is in centimetres and this is in centimetres. Okay, so I'm just going to put that straight in. Pi times 40 squared times 160. Crikey, this is big. This is really, really big, I can't lie to you. I'm going to leave it for a moment in terms of pi. And when you see how big the number is, I feel like you'll understand why I'm doing that. It's 256,000 pi. The number is massive. It's 804,247.7. It's huge. Okay? It's a big number. Actually, let's put both. Why not? 804,247.7 centimetres cubed. Okay, and that's it, that's the volume. Okay, so if you're filling it to the brim, that's as far as we can go. We're going to fill 4 tanks of these. Okay, we'll do 1 tank at a time. Alright, the fertiliser has to be mixed with water, 1 to 100 by volume. Katrina has 32 litres of fertiliser. Okay, so we now need to, we might as well actually find what our volume's going to be completely actually. If I think about this logically, we've got 4 tanks, not 1. So before we do the bit about the ratio, let's multiply our volume by 4. We're going to times this by 4. Okay, so I'm just going to put total volume equals, it's going to be huge. Here we go. Alright, 321,690.877. That's centimeters cubed. We might as well put this in litres now. Okay, because we're about to use litres with Karina here with the fertiliser. It tells us in the question, it's not told us for no reason, that 1 litre is 1,000 centimetres cubed. So we're going to divide this number by 1,000 to put it into litres. Okay. So we get 3, 2, 1. Let's just round up now. 7 litres. What is L for litres? Okay. Now we've got it in litres. I'm going to write it. I think it looks better. Alright. That's the total volume for the 4 tanks. Alright. Now she says she's got to mix in the ratio of 1 to 100 by volume. And she's got 32 litres of fertiliser. Alright. Now, she has 32 litres of fertiliser, yeah? So if we're looking at this ratio, 1 to 100, the fertiliser side, and then the water. She has 32 on the fertiliser side. So we need to times that by 100, okay, to get, because 1 to 100, so times by 100, we get 3,200. So the total volume that she has available to her in litres, so her total volume is going to be 3,200 plus the 32 litres. So 3,232 litres. So that's how much she has. Alright. This is how much she has. This is how much she needs. So yeah, she's all good. So yes, she has enough. Alright, so yeah, all good. Alright, and that one that's a hard question, that. I'm not going to lie to you. But you could at least, if you're thinking, I'm not sure I'm going to get all 4 on that because there's a lot of words, there's a lot going on, at least want to be getting this volume of a cylinder. If you see a cylinder, right, and it's giving you some sort of dimensions, it's either going to be probably volume or surface area. Okay, and if you're not sure, volume's easier to work out, so work out the volume. The worst that happens is it was surface area and you got it slightly wrong. Alright, it's better to have a go. Especially with these late on questions. You want to try and pick up a couple marks here and there. Okay, we've got some similar triangles. Now what that means is, it says they are similar. That means this is an enlarged version of this. Okay, sidewise. The sides are going to be a bigger version. You see the angles are the same? This is literally, you've got a bigger version of the same triangle. Right? That's all it is. So if this is 5 and this is 20, to get from 5 to 20, you multiply that by 4. Right? Times that by 4. So to get E to F, which is what it asked for, I hadn't even read that was the question yet, we just need to times this length by 4, and we're going to get 16 centimetres. Alright? Okay. Now it says work out the length AB. So spicing things up a little bit. AB. If you're not sure when you're reading these what it means by this, AB is just this one here. Right? AB is this one there. Like EF is this one. Right? Okay, so we're looking for AB. Now we haven't got AB here, but we do have DE. So we've got its equivalent line. This is its bigger version. 22. It's 4 times bigger. So we're just going the other way. So instead of timesing by 4, you're going to get your calculator out, and we're going to do the opposite, because we're going the other way. We're going to divide it by 4. It's actually not too bad a question, this. 22 divided by 4. Get your calculator out, and you will get 5.5. Very, very doable. Alright, for anyone. I don't care if you've got grade 1 or you've got a grade 5. Anyone can give this one a go. Okay, just know they're similar. all that means is it's a bigger version in this case. Alright? Alright, probability trees now. Okay, a couple of key facts we're going to need before we can even attempt this question. We need to know that probabilities total to 1. Okay, so if it's a 50% chance of raining, that means it's a 50% chance of not raining. Yeah, that's 100%. Or a 0.5 and a 0.5 makes a 1. Yeah, so it only ever totals 1. So if it's at 0.3 to win, this needs to, then do not win will be the rest. So that would be 0.7. Okay, so I've not even looked at the question, all the words and all the faff. We've just been asked to complete it. We're going to crack on and complete it. Okay, it says on this one, so that's the sports quiz only. Alright, that's just the sports quiz. Now we're looking at the music quiz on this side. 0.35 chance to win the music quiz. So we're going to do 1, take away 0.35. If you're not sure, you can use a calculator, but you will get 0.65. Alright. And again, same at the bottom here, 0.65. Just filling in all the gaps. Alright. So now we're going to do part B. Work out the probability that the Keddy family will win both the sports quiz and the music quiz. So we're talking about double winners here. Alright, so we're going to follow a bit of a path. So what does it say? They're going to win the sports quiz. So that's this path here. And then they're going to win the music quiz as well. So that is this path here. Okay, so that's the path that we're taking. Alright, following it on like that. Now to get the probability, we're going to use these two numbers here. Okay, and we're not going to add them up. Alright, we're not going to add them. We're going to multiply them. Alright, if we added them, we'd get 0.95. That's a very, very high probability that that would happen. That's not the case. Oh, sorry, I've done the wrong number. My apologies. Sorry. Should be 35. So it's 0.3 times 0.35. But timesing them will give us quite a small probability, okay, of this happening, because it is quite unlikely that you're going to win both quizzes. But it's still, it's possible. So you put that in, you get 0.105, or if you fancy a bit of fractions, 21 over 200. Either of those is fine, whichever way you fancy. Or you could even put 10.5%. If you really want to. I wouldn't bother personally, but if you fancy that, then go for it. Okay, any of those ways you can represent probabilities as decimals, percentages, or fractions. Sometimes it might ask for a specific one, but it didn't in this case, so go crazy with it. Okay, changing units, not easy at all for this one. It looks, you'd think, what don't I just like, I don't know, divide it by 10 or what, divide by 100 or whatever. It's a bit more complicated than that, alright, because this is meters cubed. Alright, so if you imagine you have a cube, apologies in advance, that's supposed to be a cube, I apologise. Alright, if you imagine that one of those lengths is 100, because we know that there are 100 centimetres in 1 metre. So if you made all of these 100, okay, and then found the volume, so you times them all together, you do 100 times 100 times 100. Okay, and if you do that calculation, you get 1,000,000, alright? So that's all centimetres cubed at the moment, these are all in centimetres, centimetres, centimetres. So that's 1,000,000 centimetres cubed, okay? But also you could write these, because 100 centimetres, well, that's 1 metre. Okay, so we could write these all as metres. So this is 1 metre times 1 metre times 1 metre. Okay, and if you times all those ones together, you get 1 metres cubed. So 1 metres cubed, 1 metres cubed is equal to 1,000,000 centimetres cubed. Okay, so to convert that, if we've only got 8,000 of them, we need to divide our number by 1,000,000. So we're doing, I know it's only worth 1 mark, so I'm doing a lot of faff for it, but we're doing 8,000 divided by 1,000,000. Okay, and that's going to give us our answer. And you get 0.008. Right, and that's your answer. Alright. Okay, we've got a similar sort of idea here. They've been put in the same question for a reason, because they're converting units, but they're not super nice. Okay, so we're going from 180 kilometers per hour, and I'm going to write it like this, you'll see why in a second, to meters per second. Okay, so we've got two changes here. We need to go from kilometers to meters, alright, and then we need to go from hours to seconds. Alright, so kilometers to meters. Well, there's 1,000 meters in a kilometer, so I need to multiply that by 1,000. Okay, so we're timesing it by 1,000. That's our first bit there. And then on the bottom, we're going to be going from hours to seconds. Now, going from hours to seconds is going to be, so hours to minutes, there are 60 minutes in an hour, so that would be timesing by 60. Okay, and then there are 60 seconds in a minute, so we're timesing it by 60 again. Okay, so two lots of timesing by 60. But that is happening on the bottom of our fraction. So what our number is going to be looking like, we'll start with 180. Okay, and we're going to times that by 1,000 on the top, and then 60 times 60 on the bottom. Okay, it's going to look just like that. So we're going to put that into our calculators. If you'd rather, you could just ignore the, for a moment, you could just ignore the 180. That was supposed to be a bit darker than that, if I'm honest. Okay, for a moment, you could ignore the 180 and just put this in your calculator and see what number you get. So if I just did that bit, divided by 60 times 60, that becomes 0.27777. It goes on forever. And then times whatever number you get there by 180. And you will get, to move that box out of the way, you will get 50 meters per second. Alright, that one's actually, I think, easier than part A. I think part A is quite hard. I think part B is still not easy, don't get me wrong. But if you lay it out like that, it's not too bad. Alright. Okay, we're nearly there. 30 women and 20 men at a gym. We've been given the mean height of everybody, of all the people, is 167. Okay, and the mean height of the men is 182 centimetres. Okay, and we're looking for the mean height of the 30 women. Alright. Now this is just manipulating using the mean. If we remember the formula for the mean, formula for the mean is the total divided by how many, like how many there are. Okay, so we know the mean for all the people, so for everyone. The total, we don't know. So we'll say x for the total. Okay, divided by 50 equals 167.6. Okay, so that's the formula for the mean for that one. So we can find out that x that we don't know by timesing by that 50. Okay, times it by 50. Okay, so that gives us the total height of absolutely everyone. And that might come in handy in a second. So if you're not sure of a question, sometimes it's good to just see what you can find out and see if it's helpful in any way. Okay, so that's the total height of everyone. So that's the total height of everyone. Okay, and we can do the same thing for the men now. So I'll use an M for the men. So we don't know what the men are at the moment. So say M divided by 20, because there's only 20 men, equals 182. That's the mean. So M is equal to 182 times by 20. Okay, so 182 times 20. So that is 3,640. So that's the total men. Okay, so we can say the total height for the women. We can work that out as well now. So the total height for W has got to be the total height of everyone. Take away the men. Now, I would expect this to be a larger number because there's more women than men in this question. So we've got 4740. And now we can work out the mean height of the 30 women because we know how many women there are. Okay, we know the total height is now 4740 and we know that there are 30 women. So our last final step is doing 4740 divided by the 30 of the women. Right, so 4740 divided by 30. And you will get 158 centimetres. And think about it a little bit logically. That makes sense. Okay, that number makes sense because, you know, it's a bit lower than the average height here. It's lower than the mean there because women are generally shorter. Okay, and it's lower than the men, which makes sense because women are generally shorter. But it's not crazy small and it's not crazy big. So that fits, so I'm happy with that number. Okay, we are nearly there. Or are we done? No, one more. Sorry, apologies. I thought we were done for a second. Standard form is not that bad. Okay, honestly, it's really not. I'm quite surprised how late on it is, if I'm honest with you. We're going from standard form, which looks like this, to an ordinary number. So just, you know, your standard number. Right? And it's a negative power. So that's something we need to take into account. This number here is negative. So if it was positive, your number would be really big. But it's negative, so it's going to be quite small. Alright? And actually, I always think of this as a bit of a guessing game. Somewhat a bit of trial and error almost. Leave a couple of gaps. Now, if you remember, the decimal point starts here, right? So I'm just going to start it here. And I just need to see how many jumps it takes to get back to my original point. Now, I've got a bit lucky here, I can't lie to you, I've actually got it first time. But imagine if I didn't put a 0 there, then I'd have to add 1 in, that's fine. So we start here, 1, 2, 3, 4 jumps to the left, job done. That's it. It's only worth 1 to be fair, but that is your answer. Right, 0.000675. That's now an ordinary number. Alright. Now this one, okay, this is in a calculator paper. So, don't use your brain too much for the first part to get yourself a mark. Put that in your calculator. Don't do it yourself, put it in your calculator. And I'll show you that now as well. Okay, I've got my browser up as well. I was doing this earlier. Hopefully I'll do a bit better this time. First things first, fraction keys first. Okay, and we're doing 2.56 times 10. And you need to find to the power of that key in your calculator. Mine, I think, is on the next slide of numbers. So to the power of. And then 6. Any time today would be lovely. My apologies, you lot. 6, alright, and then we're carrying on, so we need to jump back down, times 4.12 times 10, and again, I'm getting the powers back out again, to the power of -3. Alright, you might have a slightly different negative sign, that's fine. And then on the bottom, we're putting 1.6 times 10 to the power of -2. Okay, and that's done. As long as your number looks the same here as it shows on your calculator, you'll be fine. Alright, so make sure you put that in exactly like that. And you will get, what do we get? 659,200. You do that, you get 1 mark. So that's just being able to use your calculator well. However, that is not both marks. And the reason it's not both marks, I'm going to move this out of the way now, is because it says quite clearly to give your answer in standard form. And standard form looks something like that. Okay, 6.75 times 10 to the -4. This is a big number though, so it's not going to be times 10 to the negative anything, but they always have the same layout. So you want to circle your part that is not 0, firstly, and put that at the front. Then you want to say times 10 to the something, and we need to find out what that something is. Okay, standard form is really strict on its rules. Okay, your number needs to be 1 or more. Okay, as in this number here, needs to be 1 or more, but it can't be 10 or bigger than 10. Okay, so it goes up to 10, but doesn't include 10. Has to essentially be a single digit number, if that makes sense. Okay, but it can be a decimal. So, for example, in this one, it was the one at the top, it was 6.75. Okay, so we need to put our decimal point in the right place that makes it between 1 and 10. All right, so the only place it's going to work is here. This is where our decimal point's going. Okay, and then to get this number up here, we're counting the number of jumps. So if we put that back into our number, imagine that's our decimal point, how many jumps to get to the end? 1, 2, 3, 4, 5 jumps to get to the end of your number. So then, that is your answer. Okay, and it's honestly not that bad. Alright, and that concludes your paper. No, it doesn't. Just a prank. My sincerest apologies. That does not conclude your paper. Crikey, this paper's long. We've got some vectors to do first. My apologies. Okay, we're on the last question, and I mean it this time. I thought the last 2 questions were last, but no, this one actually is. Alright, we're doing A plus B. Now, this is literally what it might look like to you. You might not have a clue, but you might be thinking, I don't know. Okay, so we've got 2. Oh, I always try and write fractions here. Don't do that. Okay, so you leave it as a vector like this. Alright, so you're doing 2 plus minus 1, which is basically 2 minus 1, which is 1. And then you're doing 3 plus 2, which is 5. Apologies for my reminder popping up then. Alright, so we've got 1, 5. That's your first answer. Second one says 2a. So all we need to do is double these numbers first. So that's going to be 4, 6. Take away c, which is 4, 1. Alright, it says leave it as a column vector. I just realised there were spaces for them to do it, but I've done them in my own space. 4 take away 4 is 0. 6 take away 1 is 5. Alright, that's it. We are 1 mark away from completing this paper. Alright, 1 mark. Come on. Okay. From the point P, draw the vector 2D. Okay, so vectors tell us the top number tells us how far across it goes, and the bottom number tells us how far up or down it goes. So I can tell you straight away that the x for the vector of just d, so this is just for d, is going to be 3 in the x direction, and then it goes down 2. Okay, so it's going to be minus 2. 3 minus 2. Alright, so if we're looking for 2d, I think it's asked for 2d, hasn't it? Yeah, 2d, which is double both of those, so we get 6 and negative 4. So we need to go across 6. 1, 2, 3, 4, 5, 6. In fact, I'll do it as a dotted line. 1, 2, 3, 4, 5, 6. Okay, and then down 4. So 1, 2, 3, 4 to there. Alright, just double check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Smash in. Alright, and then you just draw yourself a line. So I'll get the ruler out. Draw yourself a line from there to there. Alright, pop a little arrow on it because it tells us the direction. Alright, and then label it 2D. Alright, and that is job done. That is our last and final mark in this, what was quite a long actually, 80 marks. Alright, thanks for watching, guys. That concludes the series of the free November 2022 series papers. Hope they're helpful to just help you guys out when you're revising. And if you get stuck on any of them, you can just pop in and out. Not expecting that you've necessarily sat it for the whole thing, but fair play if you have. Rate that for you. Alright, catch you in the next one.